Okay. We are going to introduce the topic of functions. Functions are an interesting part of mathematics that we really like to investigate. And, well, how about this? We just graphed circles in our last unit. Are circles functions? Why? Because they don't pass the vertical line test. Very good. Now, that is not how we define a function, something that satisfies or passes a vertical line test. If you flip over the back side, you're going to want to write this down. You do have to memorize this for your next test. Let's define a function. So somewhere on the back side, write this down. Now, there's many ways to define a function. Your book chooses one that I don't really like. I'm going to choose something that, I suppose if a college math professor is viewing this video, he might say, well, your definition is not exactly correct. This is going to be very satisfactory for your needs. So, definition of a function, a relation. And by the way, a relation is just a set of ordered pair. Okay. So it's just a very specific relation in which every element of the domain corresponds to exactly one element in the range. A relation in which every element of the domain corresponds to exactly one element in the range. Okay, that should be pretty straightforward, something that you do need to memorize. Again, for your test, you need to memorize that definition. It will be on there. Just as I asked calculus to memorize the precise definition of a limit. Other things as well. You want a SON for this? Oh, whoa, they want a SON. All right. Tara, you write one, and we'll do it tomorrow, okay? So, let's try to look at an example here. Riz, what number are you in soccer? 9. Savvy? 12. Do we have other soccer players here? What number are you? 0. Alex? 22. Boss? 19. Just girl soccer players. All right. And how about this? Okay. Riz, how many goals did you score? Last game. Last game. Just the last game. 0. Savvy? Yeah. Okay. Who's 0? How many did you score, Hannah? 0? 0? Okay. So, if I were to map the elements of the domain to the range, is it possible to have all these players score exactly 0 goals? Yeah, it just happened. All right. Now, let's suppose that Riz gets done with her game and she says, I scored 0 goals. But when she's talking to Miss Nelson, she says, oh, yeah, I scored 3 goals. Could number 9 score both 0 and 3 in the same game? No, we would call her a liar, liar, pants on fire. Exactly. You are. You're a liar if you say that, Riz. Don't say that. That's an example where that's no longer a function. That's not possible. You can't have a domain element give you more than one output. When we put something in, we have to know for sure that we get just one thing out. Now, graphically speaking, some people think, is this a function? No, if it crosses up here at 3 and down here at -3, you can see that it has the ordered pair 0, 3 and 0, -3. That means a domain value of 0 and a range value of 3 and -3. So 0 goes to 2 values. You can't have that. That's not a function. And if we don't have a function, it's very hard to do anything with it. As a matter of fact, it's very hard to do calculus with it. We know how to work around those things, but it's difficult. We like functions. So that's what we're going to start studying. You're going to need your graphing calculators, by the way. So let's start out with some easy problems. Given the following functions, evaluate f of negative 3, f of 2, f of a, and f of a minus b. These are your domain values. They are the inputs. We can be guaranteed that if we plug it in, there's only one value that we can get out. Now, is it possible that negative 3 and positive 2 would come out with the same value? Is it possible I could plug in negative 3 and positive 2 and end up with the same function values? Can Alex and Riz both score the same number of goals in a game? Yes. So I could plug these two in and get the same value as an output. Is it possible I could plug in negative 3 and get two different outputs? No, that's not possible. So let's evaluate this. How do I do f of negative 3? What does that mean? What does f of negative 3 mean? Negative 3 goes in for x. Good. So 3 times negative 3 minus 5. What is that? Negative 9. Well, what? No, it's not. Negative 14. Negative 9 minus 5 is negative 14. F of 2. 3 times 2 minus 5 is 1. What's f of a? Very good, Megan Boss. 3a minus 5. And what is f of a minus b? That looks difficult. I would have 3 times what? 3 times a minus b minus 5. How do you simplify that? 3a minus 3b minus 5. Which of those terms can I combine together? None of them. They are not like terms, so I'm done. Now, that may seem odd to you that you would have an expression like that, but I want you to understand that the further you move, and especially in calculus, Chrissy and Taylor have actually been plugging in a plus h a whole heck of a lot these past couple weeks. And that's what they're doing right now. And they're kind of getting tired of it, but they have to continue to do it, and they have to do it for very difficult ones. So I'm using this to prepare you for next year, as your book does, and they do a good job. Now, as I said before, excellent mathematicians know how to check their answers multiple ways. So we have f of negative 3 is negative 14. I think you can feel confident that's correct. Let's see how you can check it on the calculator. Take out your calculator, turn it on. We go into y equals, and let's clear out those two values. Well, that was from calculus. Never mind. Now, what I'm going to do is I'm going to plug my function into there. I go 3x minus 5. I'll wait for everybody to type that in. We want to go to y equals and do 3x minus 5. And let's all look at it in the same viewing window. So to do that, I press what? Zoom 6. Zoom standard. And that's the line that I get. I want to know if x is negative 3, what is the y value? I go second, calculate, and anybody know what I grab? Which one? I want to know the value, number 1. I want to know a specific value. X is equal to what? Negative 3. And as long as negative 3 is in my window between negative 10 and positive 10, I'm okay. Let's say I wanted to know negative 14. I would have to expand my window. But I just type in negative 3 plus press enter, and it says it's negative 14. Your calculator will generate those values for you. That's one way to do it. Here's another way to do it. We can use our table. Go second window or second table set. Let's start our table at negative 3. Anybody know what this delta table or triangle table thing means? That's how much your x values will go up by each time. We could change it to 1. Yep, we could change it. Yeah, most of yours should be at 1. And we're going to have both of these on automatic. Now if I go second graph or second table, you can see that your calculator makes a table for you where you can see all the values. You can see negative 3. If you plug it in, you get negative 14. What if I wanted to know negative 3.1? How would I do that? I could go back to my table set and change my delta table to 0.1. And now when I go to my table, now I can look for negative 3.1. It's going to take a little while for me to get there. I could change my starting spot so I wouldn't have to scroll through all of these. So I end up with negative 3.1 being negative 14.3. And there's one more way, and this is the way I like to do it, is if you go to your table set, let's just say instead of automatically generating new values, I want you to ask me what my independent values are. And if I tell it to ask me, and I go to my table, then I just punch in that negative 3. Or if I want to know negative 3.1, I can generate that. Or if I want to know negative 258.693, I can do that, and it will calculate that as well. So your calculator has that capability. Any questions? You should be ready and capable and willing to use your table or those checks on your calculator. Oh boy. Well, you're all here tomorrow. Second hour, we didn't get through this. Let's just do example 2, and we'll be done for the day. All right. So this is f of x. Okay, so we plug in negative 3. Let's evaluate this. What's negative 3 squared? 9 minus a negative 6 is going to give me a positive 15. Then I plug in 2. F of 2 will be 2 squared minus 2 times 2, which is 4 minus 4, or 0. What is f of a? Very good. A squared minus 2a. And f of a minus b. How will I do that? How do I do that? Not factor, but FOIL. So I have to put the a minus b in for both pieces. And now I'm going to take Alex's advice, and I'm going to FOIL that out. What's a minus b quantity squared? A squared minus 2ab plus b squared plus 2b when I distribute the negative. What terms can you combine? None of them. So tomorrow we pick up with example 3, and you'll have an assignment to work on. Okay. So no homework tonight.